Hello everybody and welcome to the 13th tutorial video in our machine learning with Scikit Learn tutorial series. In this video what we're going to be talking about is actually applying Linear SVC to our actual problem here and see what we can figure out. So in this video we're actually going to only have two features. We're going to use two features rather. We've got a lot of features. In this video, just two features. We'll kind of go over some of the basics here. I don't think we'll find anything too powerful with even these two features because this can actually still be done, by very simple code. Actually, you don't even need machine learning. You can visualize it yourself and see if there's anything there. So anyways, let's go ahead and get started. So let's make some imports, and so we're going to have basically a few imports actually. So we're going to import NumPy as MP. This is to convert to a NumPy array, basically, that's it. Import matplotlib.pyplot as PLT. This is to make plots, because we're going to show it visually. From sklearn, import svm, because that's what we're using. Then we're going to do import pandas as PD. Then we're going to do from matplotlib import style. Then we're going to have style.use ggplot. ggplot. Anyway, in like 5 years, people will probably watch this video and be like, I don't get it. Anyway, probably a bunch of people don't get it anyways. Moving on. So that's just to make our plot look kind of pretty. So now what we need to do is we're going to first build our kind of data set. So we're going to have two functions here. The one function is going to actually run the machine learning kind of algo and graph it if we want it to. And the other one's going to actually build the data set to feed it through Scikit Learn. So Scikit Learn has a it's very particular about the way you feed data through. You feed through data as X, Y is target, capital X, and then Y is target. So let's go ahead and define build data set like that. And here we're going to have a parameter called features, and that's going to equal the following. We're going to look for DE ratio. And our other feature will be trailing P/E. Cool. So that's our function and its parameters, and our name and parameters. Now we're going to say data_df, and that's going to equal actually it's pd.dataframe.from_CSV. And here you put the name of that CSV that we saved it to. I believe it was just key_stats.csv. So that's our data frame. Next, what we're going to say is capital X. Again, I think the purpose of capitalizing X is just to not be confusing, because the variables are X and Y, but X is actually your coordinates, and Y is actually your target or the actual number, whatever the classification is that you know. So anyways, X equals mp.array, so the conversion of the array of data_df, and that is features .values.toList. So this looks a little confusing. You might kind of gloss over what this line is doing. So let's go ahead and just kind of say what's happening. So when you say data features, what you're doing is you're basically saying data. I'm trying to think of how best. I feel like some people probably aren't left behind, so I want to describe this fast enough. But then some people probably are very confused, so I want to describe it. So data_df features, it's kind of like saying basically DE ratio. It's basically saying for pandas data frame, I want these two columns considered, and then it converts those two columns. When you do .values, it converts it to basically just those values, and then you say .toList, it converts it to a list, and .toList converts it to a Python list, which and in fact, curiously, we might not have to do .toList. I'm actually kind of curious. First time we run this, I'm going to do this, because actually what we're doing is we're converting this to a two-dimensional array. So it's a list of lists, and then we're converting it to a NumPy array. So I'm not really actually sure .toList is necessary for us. So let's go. We'll leave that there for now, and then if we need it, we'll bring out this comment again. So anyways, then we're going to say y equals the following, and this is going to equal data_df and it's going to equal the value of status. And if you don't remember what status was, it was either outperform or underperform. Now, those are words. We need them to be numbers. So y is equal to data.df status, and with pandas data frames, you can run a replace function on them, is just like you would any other string if you wanted, or really anything else. So we're going to do that here. So we're going to say dot replace. And we're going to replace underperform, and we're going to replace that with a 0. We're going to say, get out of here. And then we're going to do dot replace outperform with a 1. And then we have the same dot values dot to list. This one needs to be converted to a list for sure. Also, so let me just do this real quick. Dot values dot to list. And that's it. Just a little quick thing. This is one line. It's long. It's appearing on my screen just fine. But another thing you could do, since we encase this in parentheses, you could do this: enter, enter, enter. So that's your x. That's your y. Then we can return capital X, comma y, lowercase. Okay. So that builds our data and returns us a data set that is acceptable to us. Now we actually want to run analysis on it, and the analysis is, should be pretty familiar to you guys. So we'll do define analysis, and analysis does the following, and it says x comma y equals build data set. So we already kind of know what's going on there. Basically, all of this code will be code you've already seen us do simply. With our own data. Let me make some space real quick. Okay, so x comma y equals that. CLF is going to equal svm.svc. Our kernel will be, you guessed it, linear. We're using linear SVC. I'm not sure what that was. And then C will be equal to 1.0, just for default purposes. CLF.fit, and we fit our data. Easy, easy. W equals, so since we're graphing it, we have to do this. Typically we wouldn't even need to do this if we weren't really graphing it, but we're going to graph it. Soon we won't be graphing it, but it's always best initially, I think, to graph it so you can see visually kind of what is going on. So W equals CLF.coefficient underscore 0th element there. Then we're going to say A equals negative W 0th divided by that weight for 1. Then we're going to say XX equals np.lin space. And here, I'm just going to put in some custom code here. Normally you could just hard code this. I'm going to go ahead and say minimum of, so the minimum value of capital X, and then this, basically NumPy magic code. 0, and then to the max of this. What did you just do to me? Alright, anyway, so min to max, and that should close this off, I think, yes. So that was XX, now YY equals A times XX minus CLF dot intercept underscore the 0th divided by the weight. So this is, again, not totally necessary to understand what's going on here at this point. Eventually we will kind of go through some of this code because these are things that actually matter, and if you want to customize your code and actually do really advanced stuff, you do need to understand. For now, just copy the code. We're purely putting this in the tutorial just so we can visualize what's going on. So, don't worry too much about it. If someone thinks they can explain it really well, feel free to leave a comment below and tell us what you think's happening. Anyway, age 0 equals plt dot plot xxyy, and then we're gonna plot that as a, don't forget your comment there, black dash line. Actually, it's not capital K, it's lowercase k. And then we're going to say label equals non-weighted. Then we're going to go ahead and plot our data. So we're going to do plt.scatter, and we're going to scatter basically this right here. well, not really. Anyway, scatter that and this. So that's basically, I just copy and pasted this value. So this is the 0th element of this X array, basically to everything, and then this is the first element of each element, the firstth element of each element in that X NumPy array. So it's kind of like magical code, but I've actually, until I got to machine learning, I never saw this code in my life. And that's actually really useful code. I would have used a for loop and then created a new list. But no, you don't have to do that. You can do this. This is some really cool code. So for anyone that's still not following, I think it's amazing, so I'm going to show you really quick. So let's say X equals a list of lists. So it's a list of lists, and it does something like this. And let's say your list is 1, 3, 1, 5, and 1, 7. Okay? So X, basically this right here, if you said, like if we said X colon comma space 0 like this, it would be 3 1s. It would be 1, 1, 1, right? It's the 0th element of each element. So this is an element, the 0th element is 1. This is an element, the 0th element is 1, and so on. I think that's really cool. I was really excited when I found that code, so hopefully some of you guys are as excited as I am. Moving on. So we scatter that, and we're all set. And let's go ahead and just run a plt.show. Also, it's somewhat helpful, I think, when we have two forms of data to go ahead and plot, to label the data. So we'll label, we'll just do, no, we'll do it right here. So plt.ylabel, and the y label is going to be the trailing PE ratio. And then plt.xlabel, this label will be our DE ratio. And then plt.legend we need, and then plt.show. And then now we should just be able to call analysis, save that, run that. Wait for it. See, oh, it's capital C. My bad. Capital C equals 1.0. Let's try this again. Hopefully we get a pretty plot. It was a big data set, actually, now that I think about it. How long is it going to take? It's a lot of plots. It'd be basically 500 times 2, 1,000 plots. Or not 1,000 plots, it would be 500 plots-ish. Let's see. Would it be that many plots? Because I guess it would be actually more than that, because we're plotting each step of the way. Anyway, it's a lot of nonsense, so we'll see how long this takes. I don't recall it taking this long when it has a bigger amount of data. Most of this is actually the plotting, though. You'll be surprised how fast this whole operation goes without plotting. I was hoping to show that in this video, but this is taking a while. Analysis. I was hoping this would go. I guess while we're waiting for that, I have some more code that I want to do. So while we're waiting for that to show up, I'm going to go ahead and run as I'm talking. Anyway, okay, so we've got our little divide here, and we're like, okay, this means nothing, Harrison. So obviously this is slightly confusing. We need to color this data. I'm not going to wait for this to show up again. But you can say color equals y, and it will plot based on the value of y, so whether it was underperform or overperform. But we'll talk a little bit more about that later, I think. It's not totally necessary to plot this up again. I hate to do it again. Although what we could do maybe is... yeah, let's do this. Let's say data, let's do... close this out. And let me come up here, and let's just do, we'll do this. We'll do data underscore df equals data underscore df like this, and then we'll do all the way to the value, or the, I don't know, let's do the 100th row. Okay, so that should run significantly faster than the previous one, and it does. Okay. So we're not really sure what these two things are, but we can divide them, and we can do something like this. We could say right here, C equals W, or Y rather, and that's color equals Y, and it will give a unique color to the underperformers and overperformers, as you can see. So you can see this is mostly reds, but you've got a couple of blues, and then down here it's probably equal count reds and blues. So we would say this is pretty inconclusive, most likely. So, you know, I think at this point I'm not too interested in doing any predictions or anything like that. But in the next video, what we'll go ahead and do is add more features, so allow more features to come into this. We won't be able to plot it, but that's okay. You know, plotting it is just basically useful so you can see kind of what's happening. Now, again, here, I think if we like ran this data and tested this data, I think we'd find that, you know, comparing these two values is worthless. And again, that's most likely because anybody, you don't need machine learning to do this, right? You could simply plot up the values yourself very quick. You don't even need to know how to program. You could just do it in Excel. And you can see visually with your eyes that, well, there's really no group here. I don't really see any point. And that'd be it, right? And so, to me, I don't really see too much value in taking this too much further with the only two features. The idea of machine learning is to have many features, so it's impossible for us to graph it or draw it or even kind of conceptualize it in our head. I mean, I'm sure it's possible, like some people are capable of conceptualizing you know, 35 features in their head and creating some sort of algorithm on their own, maybe. But I don't think that person exists. And I mean, maybe they do, but it would take them a long time probably. But most of us can't do that anyway. So just for a quick, I believe this is our outperformers and these are our underperformers. And so you can see trailing PE, the price is significantly above. I would go so far as to say the reason for this is trailing PE is based on their past performance, right? Their trailing PE is how are they doing based on their equity from before compared to their price basically today. So it only makes sense that the people that are outperforming today have a significantly high trailing price to equity ratio, right? Because basically what it's saying is they're worth more than their trailing equity. Okay, so basically, if you ask me, that is almost 100% going to be the case that people are going to have a high trailing PE if they are outperforming. It just has to be the case, right? Pretty much, anyways, as long as in the time period the market has gone up, I suppose. But anyways, enough of that. This is not really that interesting to me, and it's cool to see it all graphed up and colored, and you know, everybody loves graphs. But what's more interesting is what's coming, and that is the analyzation of, you know, 35 features and seeing if there's anything there. So anyways, stay tuned for that. If you guys have any questions or comments, please feel free to leave them below. Otherwise, as always, thanks for watching. Thanks for all the support, the subscriptions, and the donations. And until next time.